So in this section, we are going to simplify variable expressions and go through a couple of the definitions of what each term is. So first, let's start with just defining terms. We see here that terms could be a number, a variable, or the product of a number and one or more than one variable. So it is a piece of our expression. So a term could be 3 or 2x or 5x, y. These are all terms. When we have terms, more than one term, we have them separated by either addition or subtraction. So the 3 that are presented right now, they're just one term. But for example, if I had 4x minus 1/2 z, these are two terms. The first term would be 4x, and subtracted from it would be the second term, 1/2 z. Often when you have multiple terms, some of them could be like terms. Now let's look at that definition. Terms that have the same variable, and keep in mind that variable has to have the same exponent. For example, 2x plus 4x. These are two like terms. 2x squared minus 8x squared. These are two terms and they are like because they have x's and they are both raised to the second power. But if I have 4x minus 5y, these are not like terms. The last example, if I have 4x minus 5x squared, these are not like terms because this x is raised to the first power. Even though it's not written, it's implied. And this x is raised to the second power. When we have like terms, we are going to be able to combine them. So you'll see those in the examples that follow. The next definition is when we have a constant. If we have a constant term, that's defined as a term without a variable. So in that first example here, 3 is a constant term. If I have 7x plus 6, 6 in that example would be the constant term. It is the numerical term that does not have a variable attached to it. So now let's look at that next defined term, and that's coefficient. The coefficient is the number that is being multiplied to a variable. So if we, again, looked here, that first term is 7x, 7 would be the coefficient. If I looked at this example, 5x squared, the 5 would be the coefficient. Be mindful though, folks, if I have 9x squared plus y. Let's look at that y term. What is the coefficient for that y term? There's nothing written, so it is implied, again, that 1 is the coefficient for that y term. So here we're going to do some simplifying when we've got multiple expressions. And by doing that, we mean we can combine any of the like terms. So let's look at example 1. We have 4x plus 3y plus 6x. Identify which terms are the like terms. Yes, 4x and 6x. So we can, off on the side, combine and see if I have 4 x's and I add 6 more x's to it, how many x's do I have in total? That gives us 10 x's. And so we've got 10x, so we have combined these two terms, and then we just bring down that solo term. And so that simplified gives us 10x plus 3y. So let's look at question 2. And we'll do a few of these, and then I'm just going to show you the worked out solutions for the remaining ones. If I look at problem 2, and I'm identifying the like terms, I see a 4x. I also see a minus 6x. That 9 does not have an x attached to it, so that's not a like term. And then I have the 2x. So off on the side, we are just trying to simplify 4x minus 6x plus 2x. We're trying to simplify the like terms. So let's do our left to right. So if I have 4x minus 6x, that gives us negative 2x, and then I bring down the plus 2. Look at that. And that gives us 0. So problem 2 simplifies to get us negative 9. Let's jump around and see if we can't work some of the other terms or problems. Let's look at 7, for example. For 7, I have negative 6 multiplied to that quantity x minus 4, and then plus 12. So you'll remember one of our properties is I distribute. So the one thing I want to do is distribute the negative 6 to both terms and then look to see if I can't combine any like terms. So that gives us, if I multiply negative 6 to x, negative 6x. If I multiply negative 6 to negative 4, a negative times a negative is a positive, and that leaves us with positive 24. And then I bring down the plus 12. Can you identify the like terms in this problem? Yes, they are the 24 and the 12. So if I have 24, and it's a positive 24 plus 12, that leaves us with positive 36. And then I also bring down the negative 6x. All right. So let's look at 12, and then I will just put up the solutions to the rest of these problems. So 12 reads 20 minus that quantity x minus 6 plus 3x plus 9. Folks, we are going to distribute first. So that looks like 20, and I'm distributing that negative to both terms. So that negative is, again, it's the same thing as saying negative 1. So if I have negative 1 times x, that's negative x. I could also write that as negative 1x. If I have negative 1 times negative 6, negative 1 times that minus 6, a negative times a negative is a positive. So now our work looks like this. And I want to identify the like terms. So I'm seeing 20, I see a 6, and a 9. Those three constants I'm going to try and combine. So 20 plus 6, I'm going to do this off on the side, is 26 plus 9, and 26 plus 9 is 35. And now I'm going to look at the other two terms. They are like terms. I have negative x plus 3x. So negative 1x plus 3x leaves us with 2x. And the last thing we do is attach that's a positive 35, 2x plus 35.